Hi everybody, my name's Craig, I'm 38 and today we're going to be talking about equatorial mounts. So, when you're starting to build your equatorial mount, what you need to do is you need to start from the ground up. Now, normally this would mean with your tripod, but actually have a think about where you're going to be putting this thing, because if you're putting it on grass, you've got to think, well, with the amount of weight that's going to be on it at the end, is it going to sink, is it going to move? If you're putting it on wood, it might vibrate if you're walking across it. Now, if you're just observing, that's absolutely fine, but if you're going to be doing any photography, it's going to absolutely wreck it all. If it does move at any stage while you've built it, you're observing, anything like that, if it shifts slightly, your alignment's going to be out and you're going to have to go straight back to square one. So, once you've thought about where you're putting it and you're confident that where you're putting it is a nice safe place, what you want to do is just extend the legs out so that they are roughly leaving the top of this about waist height. It'll just make it much easier for observations, moving it, whatever. Once you've got this raised up to waist height, there is a small metal nodule, if you like, that sticks up from the top of one of the legs. Now, this ideally needs to be pointing roughly north. The reason being is because when you do polar align your scope, there are going to be some little fine adjustment knobs. They're going to want to be on the north side. So if you pop that little nodule roughly to north, then you're in a good stance. Make sure that the legs are opened out completely so that, again, it's less likely to move or anything like that. Some people do actually weight these down if they're made out of aluminium, like this one, just to make sure that if it's windy or anything like that, it's less likely to move. You also get a small spirit level on the top of most of these mounts. Now, you want to make sure this is as level as possible. The reason being, again, is because when you polar align and you're tracking things like that, it needs to be level with the earth, otherwise it's going to go higher or it's going to go lower. So, all of these steps are very, very, very important. They're all very small. It's quite methodical the way that it does come together, and it does make sense. Once you've done it a few times, you're not likely to forget any of the steps, but they're all as important as each other. So now we've got it on stable ground, it's level, and we've got it roughly pointing north. This is now when you can start to build it up with the rest of the mount. So the next part of it is the mount itself. Now you'll notice there's a couple of things on here. One, it weighs about the same as a neutron star. It's got two big ass weights on the bottom here. It's got a little mini scope in the middle, which you're going to use to find Polaris. And then it's got your mounts, which will hold your scope. Now these can differ. If yours look different, don't worry about that. Remember this little nodule that we had over here? This is to go in the middle of these two screws here. These are your fine adjustments. This is why it only needed to be roughly pointing north. Now the idea is that if you do need to ever so slightly change your polar alignment, you're not going to have to move the entire scope, you're only going to have to twist those little knobs down there. So, I can't talk while I do this, I've tried, failed. So the next step, now that we've got the mount roughly pointed north, you need to make your life easier when it comes to polar aligning. Now, one way to do this is to get the elevation right as well before you start. Now, the way to do this is, obviously the Earth is round, we all have a latitude of where we are. Just on the other side of this scope here, there is a little dial that takes you up from 0 to 90, obviously, I don't know why I had to check that. So what you want to do is to set that to where you are on the Earth. Now, here, I'm 53.8, so I'm just going to set this to 53.8. All you've got to do is just undo the small loosening lever here. Lift it up till it gets to 53.8 and then lock it back down. So now, not only does the mount know where north is, it also knows where I am on the Earth. Now, this little finding scope here, this is for Polaris. Now, if you're in the southern hemisphere, all I can suggest is to move house. The north is not that bad, it's not Game of Thrones or anything like that. There is a southern star which you can use to polar align in the southern hemisphere, but unfortunately it's not visible to the naked eye, so it's not the easiest to use. It's time to get it polar aligned. it's at the right altitude, so we know that Polaris should be in the viewfinder if it's facing north. If it's slightly out, that's what these fine adjustment screws are for, to just slightly skew it left and right to get Polaris in there. Now you will notice there's a crosshair and there's also a small circle. This is because Polaris doesn't stay in the exact same spot all the time. It does move around. So if you just Google Polaris location, it will show you where it is on the circle, match yours up with what you see on Google, and you are polar aligned. What we need to do now is get the scope on. Now, I also have a habit of losing things or forgetting things. The best thing is, as soon as you're done with something, just put it back. Turn off your laser sight. If you've got a laser sight on your telescope, always be turning it off. I'm going to make a little sticker on the top of mine because the amount of batteries I'm going through is costing me a fortune. Now, here we have, courtesy of Tony, my driving instructor, an 8-inch Dobsonian telescope. Now, I have made another video where I go through the different types of scopes and I explain why I didn't buy this scope. If you're interested about different scopes or you're looking at getting one and you're not sure which one to get, just drop onto my other video. It's a fairly comprehensive review in about 10 minutes, or as comprehensive as you can be in 10 minutes anyway. But it just explains the different types of scopes and why I made the decision to not get one of these, which most astronomers would recommend as a first telescope. But like I say, maybe it's just because I'm not conventional. Who knows? Now, these aren't the easiest things to do. It's probably easier to do it when the scope is flat. You can by all means move these around while you're adjusting them. There are some levers on the mount which you can just set them all to loosey-goosey while you're getting everything set up. Now I've got a scope on, what is important to do now is balance it, because if you've got too much weight on one end, it will move. Now, if you're doing astrophotography or even if you're just viewing, this is going to be highly annoying because you're not going to be able to keep something in view if the telescope is wanting to move all the time. So, in order to balance it, what you need to do is, as you can see, this is tilting back. Now, the reason it's tilting back is because all the weight is in the mirror at the bottom. Now, if you were to have a big DSLR or anything on here, I would recommend setting it up as you're going to use it before you balance it. Because if I balance this now, and then I stick a whacking great big camera on the top of there, it's going to be front heavy and it's going to want to drop down. So I know it seems like common sense, but when you're setting these things up, personally I get so excited and I don't know what I'm doing, and then I miss out steps, and then you suffer for it later because, like I say, straight back to square one, any problems. So it is important to not rush these things. Take your time when you're setting these up, because I promise you it will pay off. Taking an extra 10 seconds at the beginning is worth spending 10 minutes later on when you try to rectify something. So this looks to be pretty much balanced now. It's not going anywhere. Now, once you've got it balanced this way and it's not going anywhere, what you need to do then is to just drop this lever here. You can notice you can rotate the entire scope. So what I do here, see, now I've moved it, it is actually dropping a little bit back again. So make sure once you're balancing it, you have a good move around and you know absolutely it is in the perfect position to just sit comfortably and not be under strain. How does that look to you? Looks alright to me. So now I am extremely happy with that. Get these bad boys tightened up. Now you'll notice if the telescope was too heavy, it would drop down. If the weights were too heavy, it would go that way. However, this is already very finely balanced. Now, it is very finely balanced because, as you'll notice, these weights are all the way to the bottom. So this is actually at the limits of what this mount can handle. You could get bigger weights, I suppose, but on these little aluminium legs, it's not advisable. Now, for this reason, I think this is an EQ3 mount. I mean, it's made in Soviet Russia by probably the same people that made Kalashnikov rifles, who also now make cars, fun fact. So I would say, if you were going to get more imaging equipment or a bigger scope or anything like that, this mount wouldn't cut it. But for all intents and purposes, it is absolutely perfect for this scope. So with a manual mount, you have to find the stars, obviously, through your own accord. Now, there is a couple of different ways to do this. You can either learn the night sky and star hop. So find a star that you recognise, whether it's Aldebaran or Sirius or even a planet, maybe Mars, Saturn. Start from there, and then if you know the position of the stars and where the planets are, you will be able to go, all right, that's Mars, right, cool. If I just go up and to the right a little bit, maybe the Andromeda galaxy is there. If I just go down and to the right a bit, and you can work your way around the sky from there. Remember, you've set it to be level with the Earth and you've told it the altitude. So this is mimicking the rotation of the Earth now, but in the heavens. If you do just want to make fine adjustments, you've got a couple of dials, you've got one there, you've got one on the far side here. By twisting these, it will make very, very small incremental movements. So you can just watch through there. If you notice it drifting, you can just follow it by using one of these here. Really, really good. Now, the second way to find out what you're looking for is everything has a set of coordinates in the sky. Once you've got these measurements here, matched up with the coordinates of whatever it is you'd be liking to look at, as soon as you look through the eyepiece, it should be there. And then, like I say, all you need to do is just use these two things to follow it. So, to summarise, an EQ mount. I think they are amazing for what they are. If you're going to be doing astrophotography and things like that, the one movement of an EQ mount is far superior to the two movements of an Altaz mount that goes left and right and up and down. This one is already pointed at a crazy angle, which just happens to be magical. So this only does one movement and it is far superior. Now, like I say, they do weigh the same as a neutron star. If you were going to be transporting this about, you'd have to be extremely careful not to lose a nipple or a testicle. I'm quite partial to both. It's not one of the reasons I didn't get one of these. I think I would get one of these, to be honest. So, reasons why I didn't get an EQ mount. Number one, I can't see the North Star. That is such an obvious problem, I'm not even going to go into it. Number two, I'm not planning on doing deep sky astrophotography just yet. I can't, there's too much light pollution where I live, so I'd only be doing the brighter objects anyway. Number three, as you'll see in the outtakes, I probably nearly lost a finger while making this video. If I had to carry around one of these all the time, God knows what would happen, so thank you very much. And number four, I was new to this. This was my first proper scope and I didn't want to dive in, spend $3,000 when it may not have lasted. A lot of people say start off with binoculars. I didn't want to go that far, so I just got what I thought was a cheap but good telescope with a guided Altaz mount. So, across two reasons why you probably should get an EQ mount. Number one movement is better than two. It doesn't matter what you're observing really. You can get away with doing lunar and planetary observations through an Altaz mount, but let's face it, they're always going to be better doing it through an EQ mount, and obviously you get the deep sky stuff as well. Number two, once the bug gets you, you're going to want to get an EQ mount anyway. So if you can just do it off the bat, if you can see the North Star, just treat yourself and just go straight for the EQ mount. At least then you'll be set up further down the line. If you do want to make any improvements, you'll be improving your scope rather than your mount. And number three, they are far superior. You can't get around it. There's no other way to say it. They are much better. And let's be honest, they look the part as well. Now, I do like to finish every video with a little energy efficiency tip of the day. For those who don't know, I'm an energy efficiency advisor. There is another video on why I'm an energy efficiency advisor and why I'm so passionate about it. But I just think to kind of thank you guys for staying to the end of the video, I should be giving a little back. So my energy efficiency tip of today is try to keep your central heating at 21 degrees. Now, the reason for this is that most houses, especially in the UK, will only get to 21 degrees and then they start to lose heat, or as my mum would call it, heat the street. Now, if you set it to 21 degrees, your house is going to be at the same temperature anyway, but instead of heating the street, your boiler will turn itself off and it will save you money. So, again, thank you all for watching. I really do appreciate it. Please check out my other videos. There is some more on astronomy, but there's also some on some very, very other things as well. I don't really have a niche at the moment. Everybody says, oh, you're starting YouTube, you've got to have a niche. Unfortunately, I have two varied interests and I just want to talk about everything. So if you just have a scan around my channel, there will probably be some things that you prefer more than others. That's fine. Just watch what you want, leave what you want, subscribe if you can give a shit. Other than that, I will see you all soon. Under here, that should have been tightened. Jesus. I'm going to do that again with this weight tightened. I took my fucking finger off.